Okay, let's move into some tangents and secants now. Now, I waited to give you this, but there's some strategies. Remember your sines and your cosines? It tells you that if you have like an odd power on sine, split off a sine. If you have an odd power on a cosine, split off a cosine. If they're both even, they call it the half angle formulas. I call it the power reduction formula. We use that until you don't have any powers of cosine or sine greater than 1. Now we're going to move into tangents and secants. Now the thing is, we want even powers. That makes things a little bit simpler sometimes. So if you have a even power on secant, that's great because the derivative of tangent is secant squared. We like that. Now if you have an odd power on tangent and any other power on secant, well, you can take off a secant tangent because that's the derivative of secant. And then, well, if tangent's going to give you an even power and secant's going to give you an odd power, well, then we're going to have to use a power reduction formula, which I have not given you yet. So let's jump into it. In that third case, I really won't mess with you at all. So let's see a problem. So let's say we have tangent to the 6th of x, and secant to the 4th of x. Let's see what we can do. Now that rule was telling us, hey, we're looking for even powers on secant. We have even powers on secant, that's great. That means we can break off a secant squared. So we can rewrite this as tangent to the 6th of x times secant squared of x times secant squared of x. This is going to become our du at some point in time. The issue we have is we need to change this secant squared. We need it in terms of tangent. Fortunately, tangents and secants go together. And we all know this, don't we? Tangent squared plus 1 is equal to secant squared. Just trigonometry, all that stuff that we probably glossed over and didn't remember, all the stuff we didn't like. Well, we got to use it. We got to use it. We got to be pro. So we got tangent to the 6th of x times what we're going to change it into, and we're changing that into tangent squared of x plus 1. Let's distribute in, and then we're going to be ready to rock. That tangent to the 8th. Sorry, that took me way too long to figure out. 6 plus 2 was 8. And then tangent to the 6th times secant squared of x dx. There it is. Now we can use a u sub on for tangent. We can sub in, say u is equal to tangent of x. Du is equal to secant squared of x dx. Hey, we are ready to rock. So everywhere we see a tangent, it becomes a u. So we have u to the 8th plus u to the 6th. And then just du. All right, because this. Just du now. Let's go. So now we'll take our antiderivatives. Let's add 1 to the exponent, divide by that number. Let's add 1 to the exponent. Let's divide by that number. Let's make sure we don't forget our plus c. And then lastly, we're just going to replace it in. Everywhere we see a u is going to become a tangent. So we got tangent to the 9th of x over 9. Plus tangent to the 7th of x over 7. Plus c. Yeah, doggy. What's up? We got it. For me personally, usually I'm all about sines and cosines. But, I don't know. Secants and tangents aren't that bad. I kind of like using the tangents and secants a little bit over the sines and the cosines. I don't know. I think it's probably equal difficulty. I'm just being weird. All right, let's try another. So now we got what? Let's say tangent to the fifth. Let's change it to theta. You know what I mean? And then we got secant to the, let's call it cubed. All right, d theta. Now we have two odd powers. So if we have two odd powers, that means we could probably just break off a secant tangent. A secant tangent. What's the derivative of secant? Secant tangent, or tangent secant, depending upon how you like to say it. So let's break one off of both. So let's take that. Let's reduce the tangent to the fourth. Secant squared. So we see we lost a power on both of them, and now we're going to replace it. Let me write it in a different color, and I'll write it as tangent secant of theta d theta. And we have that there. One more time. The derivative on secant of theta is just, yeah, that's right. Be consistent. You know what I mean? Call it tangent secant. All right, that's why we're doing it. So we want to change everything into secants. Well, we're going to use that formula from before, which tells us the tangent squared of theta plus 1 is equal to secant squared of theta. But we're going to want to replace our tangent. All right, we're going to want to replace tangent. So that means we need to solve for tangent. So that means subtract over the 1. So we have secant squared, subtract 1. So let's go back through and see what happens. So that's tangent squared times secant squared times tangent secant d theta. So now we can go through and replace this. Oops. Oh man, so much writing. Maybe I take it back when I was like, I kind of like these better. Maybe because I did a simple. Gosh, now I can't write. We did a simple one to start. Okay, there we go. So it's secant squared minus 1 instead of our tangent squared. Now we got to square all that stuff up. So here comes the algebra, right? So we're going to get secant to the fourth of theta minus 2 secants of theta plus 1 all times secant squared of theta, tangent theta, secant theta, d theta. Now we got to distribute this in. So you wanted to be a STEM major, huh? All right, cool. A lot of work now to an awesome job later. A lot less crap taken when you're a STEM major. The jobs are pretty dope. All right. Whoo! We can finally do a gosh darn U sub. What was that? 1, 2, 3, 4, 5 lines, and now we can do our U sub. So U is equal to secant of theta. Du is equal to secant of theta, tangent of theta. And of course, I wrote it the wrong way that time. But hey, you all know the multiplication is commutative. So there's our du. We go through. We're almost there. So it's u to the 6th minus 2u cubed. Oh. Is that right? Nope, it's not. I made a mistake. I forgot that there was a square here when we brought that through. That's not secant cubed. 2 times 2 is 4. Sorry, it took me a second to notice it. Man, I suck. U squared. There we go. There we go. Did you see that? Did you notice that I made that mistake? I went too quickly. I made a silly old mistake. So now we take the antiderivatives. We get u to the 7th over 7 minus 2/5 u to the 5th plus u cubed over 3, all plus c. And then we go through, we replace, and we say it's secant to the 7th theta over 7 minus 2/5 secant to the 5th of theta plus secant cubed of theta over 3, all plus c. Woo! What's up? That's some fun stuff, huh? No biggie. All right, so we're going to go through the next, that we'll do the tangents and the secants with just tangent, just secant. We'll do a secant cubed and we'll do a tangent cubed. Might be a longer video, but it's going to be some things that are highly important, and I think you should get a couple things memorized. So, alrighty, on to the next.